Evan, Nunu, and Ida. Automatic catfish feeder based on basic feeding practice for catfish. So we designed a product that could feed catfish based off temperature. The feeding process for feeding catfish accounts for 50% of the cost for a farmer. So our product is here designed to help farmers. Our product here is designed to help farmers minimize the amount of expensive and wasted food in the farming industry. Also, it prevents without feeding so much food, it will prevent the water from polluting and causing more problems. Suresh will give us a background on the research done.
Thank you, everyone. So the current market for catfish feeders what we have is basically a very small automation of the feeder. You can go and buy a feeder from Walmart or Academy, and they're just going to give you a feeder unit where you can either change the feed time or the duration. So the automation that is involved in any feeder is very, very small. So what we decided was, as Mike was pointing out, that we should do something more with this product and see how we can integrate and automate more sensors to this device. Next slide, please. Okay, so the background from this is the paper that I'm carrying in my hand. So this is Dr. William A. Wirtz, who's a PhD professor from Kentucky State University. And he has done extensive research on catfish farming and the feeding activities of catfish. And he has come up with these 8 basic feeding practices. The right feed, we give them the right quality of the feed. The feeding to satiation. Are you able to see the screen? Feeding to satiation. The body weight feeding, which is basically feed the catfish based on the percentage body weight. The timing of the feeding, it is very important based on the oxygen level of the water. The growth and conversion rate, you just catch them young, feed them, and then let it go to the next process. How much protein intake the catfish has to take. The multiple batch feeding practice, that is another feeding practice. And seasonal adjustments of feeding rates. That means in winter, you feed less because the catfish will not eat the food, the pellets, when it is very cold. So from those 8 principles, we borrowed 4 of them, and we are using that as our project idea. Starting from the right to feed, the feeding to satiation at about 60°F. The only way we know how we get to that temperature is by measuring the temperature of the water. And we feed in the early morning between 10 a.m. and 1 p.m. or 4 to 7 p.m. where the oxygen rate at the water level, the oxygen in the water level is more. And the seasonal adjustments of feeding rates, again, based on the temperatures. Yeah, so go ahead and please talk about the purpose.
Okay, so as we're saying again, we integrated the temperature sensor. And so basically, between 32 degrees and 40 degrees Fahrenheit, the water's ice, the motor will not spin, so there's no heating based on seasonal adjustment. 41 to 58, the water's cold, meaning that the fish will, the motor will only spin for 19 seconds, seasonal adjustment based on weather temperature. Meaning also that is half the feed time or the feed amount that a fish would take. Then 59 to 94 degrees Fahrenheit is normal. That is a full satisfaction that the fish are going to get food. They're going to maximize their food. Between 95 and 212 degrees Fahrenheit, it's too hot, the fish will not eat. Evans will speak about the implementation.
Thank you, Mike. This is our implementation. We use power supply to supply the power to the microcontroller, Arduino Uno, and the analog input is connected to the temperature sensor. The digital output is connected to the solid state relay and also the feeder unit. And this is the code that we use to run the program inside the feeder. Basically, we start and then we will initialize the all the parameters, and then the RTC will read, and on every hour, if it's feeding time, we'll go to yes. If it's not feeding time, we'll go back to no and go back to read again every hour on the hour. And when it's yes feeding time, we read and store the water temperature, and then we'll go down and look for the feeding. So if it's yes, we'll go up there, look back in the parameters and see how long the feeding is, and turn on the feeder, and then it will display on screen how long the feeding is and what the temperature is. This is part of our C code that we use for the program. As you can see, we initialize the one wire ballast temperature, and then we define the all the pins that we use on the Uno, which is 2, 0, 13, and 5. This is the lookup table. You can see if it's between 32 and 32 Fahrenheit and 41 Fahrenheit, we will feed at this time, which is 0, because it's too cold. So we're not feeding at this time. And this code will, if you want to change the time, the date, the minutes, the hours, the day, the month, the year, you can do it later. And we set our feeder to feed 3 times a day at 5, 12, and 18, according to the research paper. So you can change that easily. And Bruno will tell you more about the specs.
There are 6 main components that we use in our project. Our main component is the Arduino microcontroller, and in which we also use the real-time clock to set the time, to keep track of the current time. And we have a 24-hour format. And this is the module unit, the feeder unit that which we will integrate all the components. This is the relay module. This is what because Arduino doesn't have the capacity to run the current, so that's the reason we use that to switch on the motor. And this is the temperature sensor. That's where we measure the water temperature. And this is the power supply voltage, which we use as a 6 volt. And this is how we integrated all the circuits inside this motor unit right here. This is how we integrate all the components. This is the Arduino, this is the microcontroller, and this is the relay. This is the RTC that we use to regulate the time, because we are feeding 3 times a day. And this is a solid state relay that we regulate what we use to run the motor. And this is the motor that power supply that we use, which is a 6 volt. And this is the water, the temperature sensor that we measure the water temperature. And this is how the whole things look like. That is why we have the motor that where the unit is where this is actually the food is being dispensed, and so the circuit output.
So the power specification, this is a 30,000 barrel. It holds up to 225 pounds of food. This is directional. It's galvanized metal. We have our temperature sensor here, and it's also waterproof too, so we can have it outside so water doesn't get into the unit.
So for the future working scope, since we're only our timing to see if it's the time for us to feed or not. And then since it's the cold-blooded catfish, we also have the oxygen level, which matters a lot. So we will have the oxygen level detection sensor, and then we will also have, let's say if we have 3 different feeders, we can also connect them wirelessly, and then have far away a unit where we can collect the data by using the Raspberry Pi or some other technical component. So here is like the code and standard cost for our product. For our product, it would cost about between $150 to $180. For the environment, it's really safe to be used in the lake and pond. For ethic, it's like used units made with these materials, and it's really healthy for catfish. And sustainability is like the parts are always available and easy to replace. For the conclusion, we did make our product work. So we did achieve all the 4 points we got from the paper written by the Dr. Williams. And again, this table represents the temperature with different timing. If it's too cold, we're not feeding anything, and no amount is being dispensed. If it's cold, we're only feeding for 19 seconds, and only 1.6 pounds is being dispensed for normal temperature, 45 seconds, and only 3.3 pounds is being dispensed. For hot temperature, it's only, we're not doing anything. And then here we presented this is just a short demonstration of how our project's going to work in the video.
Less than 2 minutes.
The distance in 5, 4, 3, 2.
We want to show how far the food is dispensed using measuring tape. If you look down here, the food is around this area, which is around 16 feet. 15 feet is right here. You can see right here.
And so basically that is the end of our presentation, and we open the floor for questions.
I have a question. Regarding the sensor, that's not off-the-shelf temperature sensor?
Yes, sir.
What's the accuracy of it?
It's about 2%. 2%, yeah.
For the end user, will they be maintenance, like if they had it for a couple of years, or they have to calibrate that sensor or possibly replace it?
Not at all.
Waterproof sensor. Yeah. Yes.
What was your inspiration for the project? Who likes catfish?
We do eat catfish in Asia.
I'm a vegetarian.
No, so-
it's just unfortunate.
So you found this paper, you found all the research, so like,
He had a friend that is starting a farm and wanted to be like, hey, I don't want to just go out there and start dispensing food out there like that. Or again, you start over dispensing food, the water gets polluted, you start losing fish. 1 acre of catfish gives you $2,000 a product. So do the math, I mean, there's people out there that are doing stuff. I mean, crawfish. So they have the land.
What is the capacity of a barrel? How many pounds?
It's 225 pounds of food, and it's a 30-gallon capacity. So our product is also down to 1/20th of an acre. And the reason we did that is because we wanted to be able to spread it out. Because that's why we want to later on for future development, we're going to put our wireless system so that they could all feed in separate areas, and we're not just dispensing food in one section.
Do you have a chart showing like the average temperatures per month and whatever geological area your target area is? Or what is your target area?
Currently, we are historizing the temperatures in the Arduino, but it has very limited. I think we are right now doing about 7 to 10 days worth of temperature. Because every hour we are recording the temperature, so that's 24 readings per day. So much amount of memory is being utilized. But the idea is that we will have several of these units sending wirelessly to a Raspberry Pi or any other device, any other microcontroller with wireless technology in it. And we can send all these data there, and a centralized monitoring system can get all the values. So we do historize.
My question is, what geological area are you going to use?
So it's basically there's a temperature sensor on there, correct? So the temperature sensor is based on the water. So I mean, if you are in Alaska, and Alaska that day it's spring, and you're wanting to raise catfish for that day, this system works for you because it's reading the temperature sensor. So you go by, so it works as a system. It's a shore base. You can put it on the shore because it throws out the food, or you can put it on a pier to get deeper water system. But it's basically, it's not set for just Texas, Mexico, Canada. It's set for, it has a temperature sensor, and the feeding is based off of the temperature of the water. Fish are cold-blooded. The catfish is cold-blooded.
Any other questions? I mean, do you have to run an extension cord to supply power to it?
Currently, at the moment, yes. Our future development is also going to be solar power and battery packs.
Any other question?
I have a question. So you say that the whole idea for your feeding schedule is based on climate adjustment for the fish and also the oxygen levels.
And time of the day.
And okay, so can you explain just a little bit more why the oxygen levels are important in the feeding schedule, and are you measuring those with your
So
sensors?
for our future development, we'll have an oxygen level sensor because there's 8 feeding practices to what Dr. Williams had on his research. But out of those 8, we implemented 4, which is the temperature. You pick the best food for your catfish. But the oxygen level sensor is one of our future developments because I believe it's the higher the oxygen, the better the feed.
I'm just going to read from the paper, just a short paragraph. Dissolved oxygen levels must be higher than 3 ppm, preferably 5 ppm. For fish under intensive production, greater than 2,000 pounds per acre, the feed should be offered between 10 a.m. and 1 p.m. Under extensive production, the fish will feed more aggressively if the food is offered between 4 p.m. and 7 p.m. So he is recommending to look at the oxygen level of the water, and based on his research paper, he says that the oxygen level is fine or more than 5 ppm between 5 a.m. in the morning, between 10 and 1 p.m. in the afternoon, and 4 and 7 p.m. in the evening.
So follow-up question to that is, how much do you trust this person who's giving you this research paper, right?
It's from a university, it's like UT Tyler.
That's not good enough, right? So it's just anything that's published is not should never be your only source of information, right? So this is just a general recommendation moving forward. You really need to look at various sources of research and validate what somebody's publishing. Just because it is published, it doesn't mean that it is, the Bible or something like that. So just make sure that you widen your research sources for future projects.
Yeah, for our research purpose, he had the most concrete, and it was also more follow to everyone else. A lot of them were just forums too. So I could have been a forum here and presented that to you. So I had to go back. So a lot of the forums speak about this, and with some include a lot with what Mr. Williams was saying. So that's why we decided to go with him, because a lot of the forums and a lot of the people were saying that are raising farms and stuff like that basically included back to what he was saying. For the most part, he was like 90% of it. We're all saying this is what they did. At the end of the day, you're a farmer. You work with what best fits you and works with you.
But we will keep in mind your suggestion. Thank you.
What happened if you?
My home is about suggestion. I would suggest that you find out the performance parameters, how you can optimize what you've done right now, because you talked about oxygen, temperature, and stuff like that. So if you want to optimize, what do you think would be the major parameters to improve?
Thanks. I'll take this question. So the if I would like to do the next optimization, I would go for different water level depths. Like currently, this one sensor, you just throw it in the water, so probably it's going to go at a feet. It's just going to float either at the surface temperature or maybe a feet or below that. But the ideal way is to go to measure at 4 feet, 8 feet, 12 feet, based on the farming depth is, and then we will know more about how the water temperature is, and we can optimize this code to make it much more better for the fish. Although I'm a vegetarian.
No, I've seen feeding systems, not for catfish, which is a bottom feeding, but for the salmon, and it's actually distributed inward. So what they do is pipe through the canal, 4 or 5 feet under, so the water never gets frozen in the distribution process. And what they do is they measure how much feet per gallon they are supplying. So basically they're taking the water from the place, so they don't have to input any chlorinated water, whatever, just they're recirculating that water into the system. So that's another thing to consider. It's not just because somebody has done it over the surface, maybe even for catfish, it would be even better if the feed it's all into the bottom and not having to wait until the whole thing is starting to disintegrate until it finally comes to the bottom of the tank. Just a suggestion.
Sure.
Like when somebody says, just look at a different angle, to see how can you feed something, either by diluting water, by overfeeding, or just by sprinkling that over the surface.
Sure. We will. Sure.
I have a quick question. Has anybody seen the feeding of fish, specifically catfish?
Not specifically catfish, but actually, yes, I have actually. I've seen a lot of videos on how catfish is. Catfish are everywhere. I've seen them everywhere. I mean, like they're up, down, they'll eat anything on top of that. So.
Well, I was raised in the country, and we used to feed our catfish. I mean, kind of plain, but they knew when you were there, and they would come to the surface. So it's not like you have to feed them on the bottom. They're definitely, and especially a friend would feed his catfish, and when they knew he was there, I mean, the water boils. It's amazing. So.
As a matter of fact, in Kima, maybe for 25 cents or something like this, you can get the food and throw it, and you will see the whole.
I think they hear the clip.
Yeah, we are actually going to have $1 for this one.
But no, excellent. I think it's, especially if your friend finally finishes, that's the whole purpose of this series.
Absolutely, it's going to go there.
Thank you.